Hi AP Stat students, thanks for coming to the Unit 2 Key Concepts Review. There are 4 things that are going to take place today. I want to go through the key concepts. While I'm doing that, I want you familiar with your calculator and how you find a regression line with your calculator, as well as a mini-tab output, knowing things on your formula sheet, and then finally, at the end of the video, I'll ask you to pause, try the My AP Classroom Unit 2 progress check, come back to the video if you're struggling. There will be hints at the end of the video for those problems. Remember, I'm not in front of you guys. I'm going to go faster than I normally do because I'm not walking around taking questions. Pause throughout. There's a discussion board on your day today. If you have any questions, put those there and I'll either make a video for you to get back to you or just try to write a response to you as well. So let's get started. Unit 2 is all about bivariate data. What does bivariate mean? 2 variables. In fact, they are 2 quantitative variables. Okay, so the first thing that we did was just said, hey, let's look and let's see what kind of relationship do we have. And so over here, you can see we have a scatter plot, right? And we have the highway miles per gallon and city miles per gallon, okay? The next thing when we're looking at this relationship, we want to describe it. Anytime you're asked to describe a distribution, you're either going to be using SOCs if it's 1 variable or SUDs if it's 2 variables. Let's go through what SUDs mean. Shape. So this shape would say mostly linear, right? Anything unexpected. These 2 are kind of out there, but I wouldn't say it's crazy unexpected. The direction of the association is positive. And the strength, you're just eyeballing it right now. I talked about that oval test. You don't want to say the oval test. You want to just kind of think, oh, if I would draw an oval around this, it's pretty thin. It looks like it appears to be a strong relationship. Again, everything's always like, it appears to be when you're talking about things because you don't have the data yet. You're just speculating on what you think is going on right now based on your knowledge of statistics. Okay, next thing, explanatory response. An explanatory variable is always what you think influences the response. So in this case, and sometimes it's not known. Let's look at this one right here. They're talking about sales time, okay, is the explanatory variable. And the time is influencing the sales, the response variable. Explanatory variable is always on the x-axis, response is always on the y. Okay, so we have this relationship, right? Then what we want to do is we want to build a line that models that relationship. And what's the purpose of that line? That purpose is to be used for prediction, okay? Let me rewind real quick though, because I didn't talk about this correlation coefficient. That correlation coefficient is your R value, okay? And it's used to describe the direction and the strength of a linear relationship. Remember, this was a test question of your guys' and a lot of people got it wrong, asking if one thing causes the other. The only way you can establish causation is through a well-designed experiment. Your correlation coefficient can be anywhere from -1 to 1, okay? Anywhere in between. The closer it is to 1, the straighter the relationship will be almost a line. If it is 1, it's going to be a straight line, okay? The closer it is to -1, that just means it's going in a negative direction. The closer it gets to 0 means there's not really a relationship going on, okay? Now, just because there's a relationship does not mean one thing causes the other. Really, really, really important. Okay, next thing, let's talk about influential point and leverage. Let's talk about that though after we talk about our line here. So we have this line and this line is going to establish a model, right? A model for what's going on with this relationship and we can use that model for prediction. Now let's talk about the calculator. How do I get that line from the calculator? So take your calculator out now and what you want to do, everything comes from that, or not everything, but almost everything comes from that stat button. So I go to stat, edit, and I would have data that I would go in there. So I don't want to change that maybe to not 20, but let's say, 10, let's see, let's make this 8, let's make this 6, and let's make this 2, okay? So I have this L1 and this L2, and I'm gonna go to stat, and I'm gonna go over to, let's look at the scatter plot first. So I hit second y equals, I hit enter, on, and then I just go to, it's on my scatter plot right now. I go to zoom and 9, and you can see my scatter plot there, okay? Now to get the line, I go to stat, I wanna calculate, and we've been using 8. You can do number 4 as well, but all AP Calc, or excuse me, AP Stats students, their books, their teachers use this number 8. So I go to 8. My X list is L1, my Y list is L2, everything else stays blank, and I'm gonna hit enter. Now, this is really important, so I hope you guys are listening. Double check, you wanna make sure R showed up. So my R didn't show up, and I did that on purpose so I can re-show you how to do that if your R is not showing up. If you have your own calculator, you only have to do this once. If you're using an online calculator, you have to do it every single time. So I'm gonna go to second, I'm gonna go to catalog, I'm gonna hit the D button right here, and I'm gonna scroll down to diagnostic on. I'm gonna enter twice, and now if I go to stat, I arrow over to calculate, number 8, I hit enter on calculates, I'll see my R value there. So I have a pretty good R value there. It's close to 1. I would say it's pretty strong. All right, next, let's keep talking. The slope tells us the predicted change in Y for every 1 unit of increase in the X value. You need to make note cards for these things, you guys, and I have a little note card section over here. And tomorrow in your note cards with Opal, I will have these on there to practice. The Y-intercept tells you the predicted value of Y when X is equal to 0. Now let's talk about extrapolation. Extrapolation is where I would want to use this line, this linear regression equation. And if some of you are like, well, wait, what is the regression equation? Let's go back to our calculator. This is just from the data that I put in. But if you're going to do that, remember, you're going to say Y hat is equal to A, my Y-intercept, plus B, my slope, 0.3571x. So Y hat is equal to A plus BX. Now it's important, you have to identify the variable. So in this case, I don't have what this actual line is. I would put Y hat, I would put sales hat is equal to whatever the Y-intercept is plus the slope times the years. And I'm gonna give you guys practice problems on that. So if you have questions, I'll catch them while you guys are doing that when I'm grading your guys' homework on the classroom. Okay, we good? I hope we're good. We're at 7 minutes. I want to be done because I know you guys have a lot on your plate, so let's keep cruising. What is extrapolation? So extrapolation would be if I was going to use this line right here, and I wanted to go outside of the domain. So it looks like what I can see, the last X value I have is 9. The first X value I have is 1, okay? So if I wanted to use this line to predict something when X was equal to 10 or 11, even 20, that's extrapolating, and that's a risky prediction because this line is only based off data from the domain of X equals 1 all the way to X is equal to 9. I can't promise that that relationship will stay the same. What if it drops down? That's why it's a risky prediction there. And so anything outside of that domain is called extrapolating. Next, let's talk about the residuals, okay? The residual is, and those of you who had me first semester, remember I was telling that story about Mr. Opal and I shopping for a mixer and coming up with a line and a cost based off the weight. I'm not gonna go into that story right now because I wanna keep it short. But what is a residual? A residual is the distance from this little point right here to the predicted Y, okay? And you take your observed Y. So the observed Y in this case looks like it would be maybe 7.9, okay? And the predicted Y, when I plug X into the formula, into that regression equation, out will pop, it looks like it might be an 8.5. So the difference, okay, maybe a little less than an 8.25. The difference between these two, the observed Y minus the predicted Y, is your residual. And again, I picked problems where you're gonna practice that. Now, why are our residuals important? Our residuals help us when we plot them out, that residual plot. It tells us how appropriate it is to use the linear model for prediction. And in class, I talked about sometimes like, could I use a ruler to measure my height? I sure can. However, it's not the most appropriate measurement tool out there. Maybe a tape measure would be better, okay? Same thing here. If our residual plot looks really nice and evenly scattered up and down, there's no what we call pattern, okay? Then what we would state then, because our residual plot has no pattern, our least squares regression line is appropriate to use for prediction. If our residual plot has like a U, another one is a fan, so it would be real close together, and then this variation would go up and up and up, or what we call a broom. So if you tipped it over, it'd look like a broomstick. Okay, that's another one that's not bad. And I've been teaching AP long enough where I can predict it's going to be really clear cut. You're either going to see something, maybe not this clear cut, but it's going to look either very nice and scattered, or it's going to look very inappropriate if you get a question like that. And I'm not even going to show you how to find the residual plot on your calculator. My prediction is on the free response problem, they don't want you making mistakes on that calculator, okay? And a lot of mistakes could happen there. They want to know that you really understand the concepts. And so I'm guessing from years past, they usually give you the residual plot and then you need to comment on it. Okay, so that's the importance of the residual plot. Now, before I talk about the standard deviation of residuals, I want to talk about R squared. So how do I get R squared? So I get R squared from R. And you can look at my calculator here. If I would take this R.9 and I multiply it by itself, you get 0.81. That's our R squared. And that's talking about variation, okay? And it's talking about basically, you can see, hey, look, as I move across the x-axis, my y's are going to change, right? We can all talk about that. In this case, let's just pretend that the R squared was actually 81. You would say 81% of the variation in y can be accounted for by the least squares regression line of y on x, which means there's a missing percentage there, right? Okay, what's the missing percentage? 19%. 19% is due to other factors. So this change in y as I move across the x-axis, 19% is because of other factors. And again, no, I remember, you guys, I know that the R I have here in my calculator is not the same R that you would get here. I'm just trying to give you a quick summary. And if you have questions, again, remember to write those down. Okay, next, standard deviation of the residuals, okay? The standard deviation of the residuals tells us the average error. So you say when we use X to predict Y, we'd be off by an average about this. How do I find the standard deviation of the residuals? That is typically on a Minitab output, and that's what I'm going to predict that they'll give you, okay? Because I want you to become one with your calculator, know where everything is, but I'm really predicting that they're going to give you a chart that looks something like this. Now, I don't believe that they will give you this, because what they're going to want is they're going to want to make sure that you know, based off of a Minitab output right here, that you can come up with the equation, okay? We know that, we know what these values mean. And if you've forgotten, the constant will always be your y-intercept, and the number right below that, that value right there, or that word right there, that's your x variable. Okay, so in this case, we know our x variable is our height, and our y variable is our volume. So we would say our predicted volume is equal to the y-intercept, so right there, plus the slope, 1.54 times the height. So that's a nice way that you can label the variables. Another way you could write it though is you could just see, and I'm gonna use, this is gonna look messy, but you could say y hat is equal to, and then what was that slope? Negative, or y-intercept, negative 87.12. Wow, that looks sloppy. Plus, I think it was like 1.53. If I'm off, that's okay, you get the point. Okay, the big thing is though, you guys, you're gonna get docked if you don't label what this x is. So that was height, right? And then this y, you cannot put volume, you guys, you have to put predicted volume or you will get it counted wrong. Okay, so that's another way that you can do it. Okay, next on here, what were we getting at? We're getting at the standard deviation of the residuals, and that is right here. You can also see your R squared value. You never use the R squared adjusted. One thing I can predict that will happen on the test, if it's a free response question, you could be asked what is the R value based off of this Minitab output. What's really important is you would have to move, now listen carefully and write this down. You would have to move this decimal point 2 to the left to make it a decimal. Then R squared, take the square root of it to get R. Now here's the important piece. Listen carefully, and you could practice this now on your own if you want. Like, let's do it. We get our R. What do we say? 0.358. So we take the square root of 0.358. Oh, sorry guys, I didn't even see that. I hit enter. I get 0.5983. Here's the catch. Remember, R can be either positive or negative. I don't have a graph. I don't know. What is it going to be? Positive or negative? Look at the slope. The slope here is positive, so our R value would be positive. If the slope was negative, the R would be negative. Again, very important part. Here's my standard deviation and my residuals. So how do I interpret that? When I use X, my height, okay, to predict my volume, I'll be off by an average of 13.40 units. Okay, there we go. Let's see what's next on our list. I think we're almost done, you guys. Hanging in there. Make sure you know, and I don't know if you can see it right now based off the video feed there, that the least squares regression line minimizes the sum of the residuals squared. So how did this line come to be? The calculator is taking all of these different residuals here. They're squaring them, they're adding them up, and they want the smallest one possible. So if I would move this line right here instead, right, those residuals are going to be much bigger, which would not minimize that sum. Okay. Last thing, let's talk about influential points and leverage. An influential point is a point that changes the slope, the y-intercept, and the correlation coefficient. So watch my cursor. That would be if I had like a point down here. What is that going to do to that line? That line is going to bring that slope. It's going to flatten that slope out. That y-intercept is going to go up, and that correlation is going to increase, because if I had a point right here now, the relationship's not as strong. If I do that oval test, the oval test has gotten bigger, right? So that's something that's an influential point. Now, what's a point that has leverage? A point that has leverage is just an extreme X value. I talked a lot about that with Shaquille O'Neal, right? So if I had, let's pretend this was our height, and our shoe size. Shaquille O'Neal's height is gonna be way over here, right? And his shoe size is up here. That's not influential because it's just confirming the pattern. But it does have leverage because it's an extreme X value. It's way over here, right? His height is very extreme. Now, on the same hand here, you can have a point that has leverage that's also an influential point. So if I had someone that was very tall way over here, but has very small shoes down here, now all of a sudden that's taking that line down, okay? That's decreasing the correlation. It's also flattening out that slope, so it's decreasing the slope and it's increasing that y-intercept, because that line, right, is now going to go down like that, which makes that y-intercept go up. Okay, ladies and gentlemen, I have the slope on there, the y-intercept. We talked about this. Just make sure you guys are making flashcards, and I'll have a flashcard session tomorrow. I think I hit on everything but the formula sheet, so let's quick look at that formula sheet, which is right here. One thing you guys need to know, and I'm going to try to find a problem for you, you could have to make a least squares regression line based off of statistics and not based off of data or a Minitab output. And that's where you're going to start right here at B sub 1, and this is your slope, okay? That's your correlation coefficient divided by this, or times the standard deviation of y divided by the standard deviation of x. You then take your slope and you plug it into this formula to get your y-intercept, okay? And then finally, you plug it into this one to get your least squares regression line. I'll find a problem for you and I'll put that on Schoology tomorrow. This point out, pause, go to Unit 2 progress check in my AP. Come back, I'm gonna quick give some hints. Those hints will take 2 minutes for me to go through, you guys. All right, you guys, good luck. Okay, if you're back now, you need some hints. The first question, forgive me, I only have hints for the first question. If you have questions on the second one, okay, I will respond to you via the discussion board. So here is the hints. Unit 2 progress check. The first part is talking about association, okay? I lied. Oh, I'm so happy. Sorry. I have these notes here that are my hints, and I was reading them wrong. Okay, so the first question is talking about describing the association, and when you're asked to describe the association, that's using SUDS, okay? The second one, a part of the question, is asking about the coefficient of determination. Just know that that is also called R squared, okay? So if you didn't know, that coefficient of determination is also R squared. Number 2, the hints that I have here is finding a residual, it looks like, and I could be wrong, and maybe this is all together, forgive me. There's something about normal. Remember, whenever you see normal, that's ZOMs. And are you surprised by low scores? If you're surprised by low scores, then you're looking at getting that z-score, getting that probability, and analyzing that probability. Forgive me if this was all one question. Just put on the discussion board if I messed that one up for the hints. And I'm sorry, I'm working hard to get all these videos done for all my classes. So it could be a mistake based off of what I wrote down. But I'm working hard, I promise. Okay, miss you guys. Take care.